we've said that whenever we're going around a circle, when we have a constant magnitude on our velocity, so it's a constant speed, we have our direction changing though on our velocity. We said that there's an acceleration towards the center that's responsible for this, and we said that that was the centripetal or radial acceleration. But what we know now is whenever we have some type of acceleration, that means that there's a force involved. So the force that's responsible for this radial or centripetal acceleration is found by summing the forces in that radial or centripetal direction, and we know that that's equal to MAR or AC, however we want to view it. So when we sum the forces radially towards the center of our curvature or circle, what we see is that the sum of the forces in the radial direction is equal to m times the acceleration in the radial direction. So what that tells us is the sum of the forces in the radial direction is mv squared over r. Now I want to take special note that this is not a force. This is the result of summing the forces. So the idea is that there's some other force from our summing, and the result of that force acting radially has the value of mv squared over r. So as an example, we can think of having a string with something attached to it, and we're twirling this object in some circle at a constant speed. Our object is sitting here twirling around. Let's say that our object is 1 kilogram. As our object is going around this circle, there is tension in the rope holding that object in the circle. This tension in the rope is what's causing it. So when we look at this object and we look radially towards the center of our circle, the force acting radially is the tension. The result of the tension is mv squared over r. If the rope doesn't supply this amount of tension, then the object would not go in the circle. And what we see is the amount of tension in the rope, it goes up with the speed. So as we spin this object faster and faster and faster, the rope has to supply a larger amount of tension. Now the rope has some, physical limit, and if you tried to spin this faster than the tension allowed for the rope would snap. There's some force or some item like the rope tension, or we'll see other examples, but the idea is that you need something supplies this. And if this force can't supply this amount, then the object will not maintain that circular motion. Something else will occur. So this is the condition for how much force you need to maintain that circle. And if your system can't supply it, then your object will not maintain that circular motion. You can think of your car taking a turn. Usually there's some radius to that curve that your car goes around. When your car is taking a turn, you need to have some force in the radial direction pulling you in. It turns out that the friction force in your tires is what's responsible. So the friction force of the tires has to be mv squared over r. If your force can't supply this, what happens to your car? Your car doesn't take the curve. It will skid for a bit until what? If you're going too fast, your car would skid until the r gets larger, and then your tires are able to then regrip and hold you on this larger curve, right? So this is the idea. Whenever you're taking some type of radial or curved path, you have to have a force that's going to supply this. If your system can't supply this, you won't maintain that radius or that curve. Something else will go on. And the idea is that this radial force is always supplied by something else. We'll see also that this, for let's say the moon going around the earth, this is supplied by gravity, or the earth going around the sun, because that's a circular path. pattern, the gravity has to supply mv squared over r to maintain orbits. So this is just a few examples of this idea. Whenever we want to go in some type of circle, we sum forces radially. The result of summing all those forces has to be mv squared over r. So the idea is that this isn't a force, but it's that result of summing forces, and something needs to supply this. If it can't supply, if whatever this is can't supply this amount, something else will happen until the condition is satisfied.